Find the range of values for k for which the quadratic equation 2x squared plus kx plus 18 equals 0 has no real roots. I've underlined no real roots here because that links us to the discriminant and the property that b squared minus 4ac will be less than 0 if there are no real roots. Helps sometimes to, in our equation, just identify that a coefficient of x squared is 2, b coefficient of x is k, and c, our constant, is plus 18. So let's substitute that into this property which we've identified, and we've set up an inequality here so that I get k squared minus 4 lots of 2 lots of 18 is less than 0. Now, simplifying this, I get k squared minus 8 times 18 gives us 144, less than 0. What I know from this, k squared is a squared term, 144 is also a squared term, so what I'm looking at here is a difference of two squares. I've got k plus 12, k minus 12. This must be less than 0. Now, since I'm dealing with a quadratic inequality, I want to make sure that I state that the roots of this quadratic inequality are going to be 12 and minus 12. And I want to sketch this quadratic in order to identify what is my region that's going to satisfy the inequality. Now, here's minus 12. At the other end, we've got 12. I want to know when is the quadratic less than 0. So the part of the graph which is less than 0 is this part of the graph under here. Now that means the range of values that I'm looking for k must lie on this part of the x-axis here, which I've marked in green. So I have a bounded region, and that means that my x values must lie less than 12 and greater than minus 12. So k must lie between minus 12 and 12. Remember to use a strict inequality. And so my final answer is that k must lie between minus 12 and 12. How are marks awarded in this question? Well, first of all, get a method mark if you identify the correct property for the discriminant. You get a method mark and an accuracy mark if you then substitute your values correctly into the discriminant in some sort of way. And then finally, you get the last accuracy mark if and only if you have expressed the inequality as I have done here. Okay, part B says is just straightforward. Solve the inequality 10x squared minus x minus 3 greater than or equal to 0. So 10x cubed, x squared, minus x minus 3 greater than or equal to 0. 10 times minus 3 gives me minus 30. I want factors of minus 30 that have a difference of 1, and we have 6 and 5. So I get 10x squared plus 5x minus 6x minus 3 greater than or equal to 0. So factorising, take the 5x out, I get 2x plus 1. Factorising my second pair of terms, I can take the 3 out so that I get 2x plus 1 greater or equal to 0. And then finally, just taking the 2x plus 1 out as a common factor, writing it at the front. Inside then I have 5x minus 3. Now, this is my quadratic. What I want to know is that my roots, again, state your roots. Roots equals, subtract, if I've got 2x plus 1, it would be minus a half. And if I've got 5x minus 3, this will give me 3/5. Remember, if you can't step straight to this, just set 2x plus 1 equal to 0 and solve for x, and then put 5x minus 3 equal to 0 and solve for x. Okay, sketch my quadratic again. My quadratic's positive, so I'm looking at a shape like this. It's going to cut in two different places, so I'm just going to put those two different places. One of those places is -1/2. One of those places is 3/5. Both fairly equal distances from the y-axis, so it doesn't really matter where I'm doing there. Now what I've got to pay attention to is I want the part of the graph which is now above the x-axis. So I'm looking at this part of the graph here, that is above the x-axis, and I'm looking at this part of the graph here, that is above the x-axis. Now the x values that generate that part of the curve are to the left of -1/2, so less than -1/2, and to the right of 3/5. Now these are two distinct regions, okay, and so what that means is this region here, let's just give myself a little bit of space so I can match it up to my curve. The region on the left here is x less than, it is an equals equality, so it can be equal to 1/2. It's x less than or equal to 1/2. And as they are distinct regions, I need to use this word or, because it can either be less than or equal to 1/2, or it can be greater than or equal to 3/5. Okay, so how are the marks awarded in this question? Well, you get your first mark if you identify these critical root values here, the roots, and then you get 2 marks if you get these inequalities correct. And at this point, if you deduct a mark if you haven't used the less than or equals to or greater than or equals to. You also lose a mark if you use the word and instead of or. And of course, the inequalities have to be the right way round, otherwise there's no marks at all. I hope that all made sense and that you understood the answer to that question.